Hello and welcome back to this series where I am teaching you all how to do archival data research in Matlab. In the last video we typed up all of this script where we took CRSP monthly return data and we showed you how to cumulate those monthly returns to arrive at the cumulative quarterly return for each firm over the sample time period, for each firm year quarter over the sample time period, and each annual return for each firm year over the sample time period. And we ended with a data set that for the quarterly returns, this was our data set. We have firm, year, quarter, SIC code 4, SIC code 2, 2-digit, 4-digit, 4-digit and 2-digit SIC industry. And then there's the quarterly return for that firm, that year, that quarter, and so forth. And then in our annual data, we ended obviously with the annual return for each firm year combination in our data set. So what I want to do in this video, as promised, we left off our code right here. I want to show you how to compute the quarterly returns and the annual returns for each 2-digit SIC code portfolio. So now we're holding multiple firms, not just one firm. So we want the quarterly rate of return for each 2-digit SIC code portfolio year-quarter combination. And for the annual, in terms of the annual return, we want the return you would get over the sample time period for if you held each 2-digit SIC code portfolio in each year. So let's go ahead first. Look at our quarterly data, which is at the firm level. And what we want to do is delete any row where the SIC code is missing. Now, I told you up here earlier when I initially deleted all rows of our data right here. I deleted all rows of our data, our initial data, which had a NaN value in any of the columns. And I said NaNs are what Matlab gives to missing values, which is true. If a variable comes into Matlab, and it has a missing value on it, then Matlab will assign a NaN to that cell. But if the variable comes into Matlab and it doesn't have a missing value, Matlab will just assign whatever's there. And so with the quarterly returns, with the SIC code, this code right here, which came in with our original data, it was right here. There won't be any NaNs in this column because if the SIC code is missing, CRSP assigns the SIC code 0 if it's missing. So deleting all rows here where there's a NaN in any column definitely won't delete any SIC codes that are missing. Unless, say there was a 0 here, unless there was a NaN right here, yeah, that row would be deleted based on our earlier code, but that's because there was a NaN here, not because there's a NaN here, because there are no NaNs in this column. So we need to go ahead and delete any row of our quarterly return data set. So there are some rows here where the SIC code is missing, which is okay in terms of our quarterly returns. I mean, we don't really care what SIC code the firm is in if we're doing firm level stuff, right? But now we're going to do portfolio stuff, so we do care. So for example, if I found the portion of this matrix where the fourth column was equal to 0, that would return, that would return this, and you can see there are portions of this quarterly return matrix where the SIC code is 0. I pulled out that part of this matrix where there's a 0 on the fourth row, in the fourth column. So we can't do anything with these. Yes, we have the firm year quarter rate of return, but we don't know what SIC industry the firm is in because it was missing. CRSP assigned it a 0 value. So we need to go ahead and delete. So all rows in our quarterly returns at the firm level matrix, we need to that have a missing SIC code, we need to delete those. So it doesn't matter here whether we do column 5 or column 4. Column 5 came from column 4. It was the first 2 digits. So if column 4 had 0, then column 5 will have 0. I guess we can just use 4 here. It doesn't matter, 4 or 5. So set this equal to empty, which means delete. When we go ahead and do the annual returns for two-digit SIC code, we also need to delete from our annual returns matrix, delete any rows here where there's a missing SIC code. So we may as well go ahead and do that. So I can go ahead and all right. Then I'm going to do is I'm going to set F equal to 5. So what's F? This is going to be the minimum number of firms required per industry year. So if an industry year has less than 5 firms, then we're not even going to conclude. We're not going to hold that industry. We're not going to hold that portfolio, that 2-digit SIC industry portfolio. We don't want to hold portfolios that have a little tiny number of firms in them. I could set this higher, but we'll just set F equal to 5, and then we can always come back in our code. And since we're making our code really general, we can just change this and see how the code changes. But the bigger you make F, the more stringent your cutoffs, and the more conservative your cutoff is, the less number of industry portfolios, the less number of portfolios you're going to have, the less number of industries you're going to hold. So we want to find all industry year, quarter combinations. I want to find all of them. So I'm going to create this new little matrix here. I'm going to call it end underscore year underscore quarter underscore return. And I want to look in my quarterly returns data, and I want to find all unique industry year quarter triplets. What are they? I'm sorry. Industry year quarter triplets. Or if you want it this way, year industry quarter triplets. And we're going to go based on the 2-digit SIC industry, not the 4-digit. I mean, so that's a unique one. 2014 quarter 1 industry 49. Were there any other firms that were in, we have data on for 2014 quarter 1 industry 49? I mean, there may be down here somewhere. We don't know from this because we have this sorted first by firm, then by year, then by industry. Then by quarter, not by industry. So there's one. Anyway, we're going to search this for all unique industry year quarter triplets or combinations. So we'll use our unique function, and we're searching quarterly return, all rows, columns 2, 3, 5. And we got to put this extra argument here, rows. So column 2, 3, and 5, and that'll pick out all rows of our quarterly returns matrix. It'll pick out all the unique rows where that triplet hasn't been seen yet in the matrix. So I don't have to write a comment there because it's right up here. I mean, I guess I can put this comment over here. So let's go ahead and run that and run f equals 5 and run this as well. I can't remember if we ran these. Oh, we didn't run any of this. We didn't run any of this yet. Let's run all this. You'll see the quarterly return matrix get smaller. The annual return matrix will get smaller. But that's okay, though. We already have saved our quarterly return. This matrix is already saved as a table here. So this is going to change. But this we still have, right? This is our firm level data made as a table. We just output this as a table, and this is a table. So yes, these two things are going to change now based on this code. But we've already made our tables. Something happened. Oh, I completely messed something up here. This should have been like that. I messed that up. So you know what I have to do? I've messed everything up. I'm going to have to go ahead and rerun this. Rerun all this. I messed up my my code. I think I just had this like that. But which rows of quarterly return do we want to delete? If you just do like this, this will combine all of the observations in quarterly return in a big, huge column vector. But it's not what we want to do. We want to take those rows, all columns. Actually, if we do it like this, then it will find those rows in column 4 which are equal to 0, where there's a missing SIC code. And those particular row numbers will just be put right here, and then it won't be treated as a row number. It won't be treated as a row now. It'll just be treated as an observation in the whole matrix. And the way that works then is it just starts in the first row, first column, and works its way down to the end of the first column, and then starts at the top of the second column and keeps counting. You see what I mean? We don't want that. We always have to do this. Rows, columns. Rows, columns. So these rows of quarterly return matrix, all columns, so those rows and all the columns in those rows, we want to delete. So basically it deletes those rows. I can run all of this and it should be good. All right. Let's run. We still have some sort of error. And I'm trying to find where it is. Index in position 3 exceeds array bounds. Oh, I see where it is. This should end there. Should be an argument there. So the unique function, we want to find the unique values in this particular matrix, which is all rows of quarterly return, columns 2, 3, and 5. So just treating that as a matrix by itself, which, and looking across the whole row, find the unique row numbers. So f has been set equal to 5, and this didn't run yet because of this error down here. So let's run that. And so here we go. Here are the unique triplets: year, quarter, industry, 2-digit industry. That's a triplet. That's unique. That's another one. That's another one. So there's 2,781 year, industry, quarter triplets. All right. Then we're going to write a for loop for I equals 1, increment by 1, go all the way up to the size of this thing we just made. Go all the way up to the size of that in the row direction. And we're going to let this thing, row I, column 4. So in this column, we're going to put how many times did we see this in the quarterly return? How many times did we see this year, industry, quarter triplet appear in the quarterly returns matrix? That's what we're going to put here in column 4 of this little matrix. In other words, how many firms were in that year, industry, quarter? 2014, industry 1, quarter 1. How many firms were in there, right? Because then we're going to apply a cutoff. We better at least see 5. Otherwise, we're not going to keep that industry, year, quarter combination. You see what I mean? So this will be the... So we're going to write a logical here. End this right here, row I, column 1 equals quarterly return row, or all rows, column 2, and end row I, column 3 equals quarterly return all rows, column 5, and this thing again, row I, column 2 equals quarterly return all rows, column 3. So this is a logical right here. And so we're asking, this right here will just be one big logical. It'll be a the number of rows that it'll have is the number of rows of quarterly return, and it'll have one column, and it'll basically tell us. So we're asking, is this in column 1? So on every single row of end year quarter return, on every single row, we're asking, does column 1, can we find that in the second column of quarterly return? In other words, like right here, can we find this year in quarterly return in the year column of quarterly return, this industry in the industry column of quarterly return, and this quarter in the quarter column of quarterly return? So let me just run this right here, but where I equals 1, just so you can see what. So when I equals 1 here, this is 2014, right? This is this would be 1, industry 1, and this would be quarter 1. So 2014, industry 1, quarter 1, and it's a logical. You see the number of rows of this logical is the same number of rows as quarterly return. And there'll be a 1 in one of these rows if on that row of quarterly return, the 2014 was in column 2, industry 1 was in column 5, and industry and quarter 1 was in column 3. So if that happened on that row, then there'll be a 1. There'll be a 1 here. If not, there'll be a 0. And then all we have to do is just sum up how many, just sum that then. Like, for example, if we sum this sum answer right here, how many rows of quarterly return was the year 2014, the industry the industry 1 and the quarter 1? 2 times. Only 2 firms did we have in that year industry quarter combination. We only had 2 firms. So all we have to do is sum this up in general across, because we're writing a for loop. And this will tell us how many. This will give us a count of how many firms in each industry year quarter triplet, or just industry year quarter. So that'll go in column 4. And so, right, there were 2 firms in this industry year quarter. There was 1 firm in this industry year quarter, and so forth. And now we can employ our minimum cutoff here. So what we can do is we can say all rows of this matrix where column 4 is less than 5, we want to delete. We want to get rid of all those year industry quarter combinations because there's not enough firms. So you guys know how to do that now, or you should. All rows of the matrix where column 4 is less than 5, we want to delete. So which rows in this matrix will column 4 be less than 5? We just write this logical here. We're going to say if it's less than or equal to 5. So it's got to be they have to have at least 6. So this deletes all industry year quarters which have less than or equal to F firms. Or if you want to say less than F plus 1 firms, that's also true. So these rows of this matrix, all columns, we want to delete. Which rows are these? These are the rows where we're looking here in the last column of this matrix, this column, and we're trying to find what are the row indices, or what are the which rows were less than or equal to F, or F is 5. So this will be a logical. It'll have a 1 if on that row it satisfies the condition, and 0 otherwise. And then we will take all those rows where there's a 1 in the logical, and we will delete those from this matrix. So F9. And so you can see end year quarter return. It was much higher than 2313, but then I didn't look at the size of it earlier, but here we go. So here are all the year industry quarter combinations we're going to keep. There were 30 firms in that combination. There were 9 in that one, 122 in this one, and so forth. And keep in mind, some industries are bigger than other industries. They have more firms in them in a given year. So, a given year quarter. So now we're ready to compute the industry year quarter return, or rate of return. And the way we do it, it's just the arithmetic mean. The arithmetic mean of the firm year quarter returns in that industry, assuming equal weighting, because the arithmetic mean means we are assuming that each firm is given that we put an equal proportion of our money. Like if we have $100 to spend and we're buying an SAC two-digit industry that has 5 firms in it, then we're going to put 20% of our money in each firm. Each firm gets 1/5 of our money, equal weighting. So if we assume equal weighting, then the industry year quarter return, In other words, the portfolio return for that year quarter. It's just the arithmetic mean of all those individual firm year quarter returns. If we assume value weighting, which is what a lot of finance researchers do, then we would compute the value weighted mean, where the weights wouldn't be equal anymore. The weights would be determined based on the value of the stock relative to all other stocks as of the end of that industry year quarter. We're going to do just the equal weighting, but with value weighting, say you want to invest, say let's just give an example. Let's suppose here, 2014 quarter one, in SIC two-digit industry 12 is what you're buying, and there are 8 firms in that industry. If you do value weighting, then what you have to do is at the end of this quarter, you have to compute the value of each of the firms, and there's different ways to do that. Market cap is what usually is done. You take the price at the end of the quarter times the number of shares outstanding, and you compute that market cap for each of the 8 firms. You sum those 8 values up, get the total value. You divide each firm's value by that total, and that's the weight that you apply to that firm. We're going to do equal weighting, though. With equal weighting, each firm would get a weight of 1/8 because we're just doing equal weighting. So the way you compute the portfolio return, what's the return on these 8 firms on holding this portfolio of 8 firms in 2014 quarter one SIC two-digit 12? It's just the average of each of the 8 firms, firm level returns for this year and this quarter. It's just the average, the arithmetic mean. That's how you do a portfolio return. Just compute the average of all the firm returns. So if we let I range from 1, increment by 1, go all the way up to the size of our matrix here in the row's direction, then on row I, we're going to let the last column be the portfolio return, and it will simply just be the mean. It will simply just be the mean of quarterly return. Which rows of quarterly return? These rows right here. These same rows up here. These rows. Which column? Column 6, or the last column, column end. I'm going to say end, though. And there we go. Because this little logical right here will put a 1, will let us know which rows of quarterly return match up with each of these triplets. So on which rows of quarterly return do you see 2014 in the year column, 1 in the quarter column, and 10 in the industry in the SIC two-digit industry column? On which rows? On these rows. So we want quarterly return, those rows, last column, the mean. Because it will be on those rows where those individual firms are located that are in that industry in that year, in that quarter. And just run this, and we're done. These are the industry year quarter portfolio returns. Now we can do the annual returns. So the industry year portfolio returns. Not the industry year quarter portfolio returns. Not the industry year quarter portfolio return, but just the industry year return. Return for the whole year if you held all the firms that were in that industry for in that year. So it's just like what we did up here. It's the same sort of. So up here we found all industry year quarter combinations. Now we're going to find all industry year combinations. So basically we're just going to copy that and paste that down here. And I'm just going to take away this. We'll call that. This will be annual return. The only thing is we got to make sure annual return, that's year. Column 4 is a 2-digit SIC industry. And column, it's just 2 and 4. Industry and year. So here are all the industry year combinations. 2014, 2014 SIC 2-digit industry 1, 2014 SIC 2-digit industry 2, and so forth. And then we do the same thing as we did here. I mean, all this stuff is going to be the same. We can just copy and paste, and we just change the appropriate things. So here we want to take away that. Take away that. Be very careful here to remove. Just change the appropriate code. That will delete all industry years which have less than or equal to F firms. We got to be careful here though, because this only has 2 columns because we don't have that quarter column. So this is going to be column 3 here, or maybe I should call it, no, I'll call it column 3. And then we want, so end year I1 equals quarterly return, equals annual return, not quarterly return. We want our annual return matrix. This has the firm level annual returns. So year is in the second column of that matrix. And then end year I3, which is, where's end year again? Well, we need I2, not I3. Because that's the 2-digit SIC industry. Where does that equal annual return? Where's the industry and annual return? It's in column 4, not column 5. And then we don't even need the quarter stuff, the other thing. We just need this. So this is a count of how many firms are in each industry year. And we're doing the sum of that. Yep, I forgot. I took off one of those parentheses. I knew that there was a mistake because there was some red over here, which means there was an error. So I ran this already, and I just need to run these. Let's just run this sequentially. So there's that. So here are all the industry year returns and their membership, like how many firms are in that industry year. And then we run this. We delete any of those rows, any of those industry year combinations which have less than or equal to 5 firms. So you can see this was 694 industry year combinations. And then when I run this, it's 573 industry year combinations because we deleted a bunch that didn't have enough firms. And then Now we just do this. Now we're ready to go ahead and compute the industry year return as the arithmetic mean of the firm year returns in that industry, assuming equal weighting and so forth. Change this to that. And it's just like what we did right here. It's the same sort of thing. Same process, except this needs to be the year here, the right matrix. And that last row of industry year return, that last column, which would be column 4 in this case, which would be column 3 in this case. We're just replacing this last column with the actual return in this year industry, because we don't need the column anymore. We don't have to know how many firms are in there, because we already deleted all the ones that have less than or equal to 5. So we don't need column 3 anymore. So I'm just going to write over column 3, the last column. I did the same thing up here. I just didn't mention it. That last column, which told us how many firms were in that industry year quarter combination, we didn't need that anymore. I just wrote over that and put the industry year quarter return in that column. And then here we want the mean of, and remember what we did up here, what we put, so this will be the annual return. And which rows? These rows. Those rows were the rows that were up here, right? We copied and pasted this part down there. So following that same process, we want the mean of annual return. Which rows, though? It won't be those same rows. A certain set of rows in annual return. And which column of annual return? Yeah, the end column, the last column, which would be this column. But which rows? And it's the rows from right up here. Following that same process, we need to copy these. These are the rows that will correspond to each pair of industry years. So there we go. Run that, and our industry year return should be calculated correctly now. And what you should do in Matlab when you're done with all your code, obviously what you should do is just go pick some random parts of your output and check it manually to see if it's right. So I'm just going to go in here and just randomly pick. I just randomly did this. 2021, 2-digit SIC industry 15. This says the annual return for that year is 59.18% or 0.5918. So 2021, 15. So go in our annual returns matrix and pull out where we see 2021 in the year column and 15 in the industry column. Pull out all of those observations. So annual return. I want those rows where the year 2021 in column 2, I think that's the year column, and the SIC 2-digit industry is 15 in the SIC 2-digit industry column, which is column 4. So those rows of annual return, all columns, we will pull out, and I'll name it test. This will be our little test data set. Whoops, sorry. I got sloppy. There is no variable in the workspace called annual. It's called annual return. There we go. So test will be that. So here's our little test data set. So here are all the rows of our annual return matrix. So all the firms, remember the perm nose and the firm column. These are all the firms that had data in 2021 in industry 15. And here here were each of their annual returns. Now we should be able to just take the mean of these numbers. So if I took the mean of test, all rows, column 5, I get 0.5918. And if I go back to my my test here, 0.5918. So I calculated manually, and I got exactly what my code calculated. We can pick another random if we want to. Let's go and test our other data set, industry year quarter return data set. Let's test this one, and let's just see if that code was right. I'm just going to pick a random industry year quarter combination. So we'll pick 2015, industry 59, quarter 4. That was the return. So to verify, let's now look in our quarterly returns data set, and let's find where 2015 equals the year and where 4 equals the quarter. I believe the quarter was in column 3. Yes. And then where industry equals column 5, 59. Or no, not 59, but what are we testing here? 59 with industry equals 59. So those rows, all columns, will pull out. Oh, again, I'm messing up here. This is quarterly return. This is quarterly return. And I'll call that test now. So here's our test data set. And it turns out there were 44 firms that had data in 2015 quarter 4 SIC 2-digit 59. And here were their respective quarterly returns. So if I take the mean of this column, I get negative 4.28% or negative 0.0428. And if we go back to our test, there it is. Negative 0.0428 is what it calculated by our code. So in summary, we're done for this video, and we were able to show you how to compute the quarterly and the annual rate of return for a portfolio of stocks, and the portfolio we chose was the SIC 2-digit industry. In future videos, I can show you how to compute those same portfolio returns for different types of portfolios. But in general, as long as you know the firms that are in the portfolio, this is how you do it. This video isn't trying to teach you, a trading strategy of how to pick the portfolio. I'm just assuming that you know what portfolio you want, and given that, what are the returns. So I hope you enjoyed this video and learned something, and I will see you on the next one.